All right, making programming fun and easy with React Testing Library. This talk is going to be about the immediate benefits of using tests with React and how to get them. My first question for the audience is, who among you does not test your code? What I mean by this is, if you write your code, save it, and then upload it to GitHub or send a pull request without ever compiling it, then type yes in the chat. So I don't see any responses in the chat. So I'm assuming that all you know that you need to run your code and check that it works before you finish the app. This talk is going to be about why you should test, how you should test. And this is mostly a beginner-friendly talk. So at the end, if you're an advanced user, I got a secret part. So that even if you know everything there is to know about React Testing Library, you don't know the end because I developed it. So let me tell you a little bit about why I'm so enthusiastic about React Testing Library. So when I was in school, before the coronavirus hit, I was taking an Android class. It took about 30 seconds to compile the app. The coronavirus hit, and I had to go back home and use a $100 laptop to write Android code. So it took about 5 minutes to run any changes in variables. So whenever I tried to run a code, it would just be painfully slow. By using testing, I was able to automatically go deep inside the code and test individual parts, and compiling only took about 10 seconds, even when I had minimal hardware. So we went down from 5 minutes of compile time down to 10 seconds. So how is testing fun? So let me tell you a secret about all games. The worst thing you can do in a video game is, when developing it, is to make it confusing. There is no such thing as having fun and being confused at the same time. Games can be hard, games can be long, and puzzles can be unclear of how to progress, but there's always clarity in what you need to do to complete the task or complete the game. Tests bring a layer of clarity not seen anywhere else in programming. Tests can also give you confidence, because when you're testing the code and this test pass, then you know that you can be confident that it's going to work. Tests also create fun because from the start of an app to the end of the app is very far away. But when you have a failing test, you know that the next step is always to make the test pass. So you have a progression from beginning to end. How does testing make programming easy? So if there's one thing I want you to know in this entire talk, is that testing makes programming easy now, immediately. Testing allows you to focus on one task at a time, which is to make the test pass. Focus gives you safety, such that debugging is easier because you got a test, and it saves you time because it's automated. It can also have you focus in on a component you want to test. For example, if you have a page that you have to click 10 times to get to, you can just render that part of the app in a test and operate on the test instantly. Now, conceptually, everybody knows you should test. There's a myth that the benefits of testing are out in the future. people think that testing is like wearing a helmet. But I'm here to change that. What you actually should think about is like testing is like riding a bike. Like manual testing is like riding a bike. You got to manually go from point A to point B using your own energy. And when going gets tough, manual testing gets difficult. Like when it's cold and raining, it gets uncomfortable. Testing provides safety, automation, and it's easy. So what else is safe, fast, and easy? Driving a car. This is what it'll feel like when you're using automated testing in your code. It'll feel like when you're driving a car to work and on your left-hand side, you see somebody riding a bike and it's raining. You know they're suffering, but you are just getting to the next step very easily and very comfortably. And your friends will think you're cool if you write tests. So you can get instant benefits, clarity, fun, and easy. But nothing in life is free. So you can get all these benefits for a low, low price of $99.99. Hello? Facebook? I'm in the middle of a talk. Oh. Well, I guess I'll have to tell them. Well, it turns out that apparently they reduced the price for all the benefits of testing. You can now get the best benefits of testing for absolutely free. So how do you write a unit test? This is what a test looks like. There's a description, there's code, and then there's an assertion. At the top of every test is either it or a test, and then you describe what the test is going to be testing, description, and then you have the code that you're trying to test, and then you make an assertion. So here, X should be 1, and you assert that X is 1. At the bottom of this picture is a test file. You got to write .test and then the extension so that just the automatic React test runner knows that this file is a test file. Also, fun fact, you might be wondering, what is this picture of? Well, this is a picture of Emacs / Spacemacs. You don't need to know what it is, just need to know that it's better than Vim. And what is Vim? You don't need to know that either. Just know that it's worse than Emacs. So, how do you run a test? You type in npm test into the terminal, and you'll run all the tests. You put this -- in between, and then you specify the file name, and it'll just run one test. For example, this ran the first example, and it passed because X is 1. If a test is failing, and you run it, it'll tell you exactly where it failed, and it'll tell you why it failed, basically. It expected it to be 1, it expected X to be 1, but it received 5 because X is 5. This is one of the reasons that tests make programming fun. Sort of a gamification. If you fail at a game, you just have to replay the level. If you fail at a test, in a unit test, just change the code to make it pass. Compare this to failing at school. If you fail at school, you're gonna have to pay thousands of dollars and take the class over again. So tests make failing easy and fun to fix. So how would you set up tests or React testing library? You need to put in these 2 programs if you're building an app from scratch. However, create React app, the boilerplate that everybody uses to create a React app already installs it for you. So if you use create React app, you just need to import the render, the screen, and the fire event from React testing library. And then just import whatever you wanted to test, and then you write the test underneath it. So some people think that front-end testing is difficult. I'm here to conclusively say that's not the case. Front-end testing is different from back-end and other programming testing because we have to deal with the UI. We have to deal with three parts of coding. There's design, and then there's the code. The design is a CSS and HTML. Luckily, we don't have to test this because CSS doesn't break very easily. HTML doesn't throw exceptions. As a matter of fact, CSS and HTML, as a matter of fact, HTML is so easy to write that you can boil a pot of spaghetti, dump it on your keyboard, and come out with valid HTML. On the other hand, you got code that breaks easily, like the configuration and the API calls, like a GET or POST request that we use very often. Supporting code on the right-hand side is code that we only have to write once because we're developing a user interface. And we're not going to be changing the back end very often, or the interface to the back end very often. So we don't have to focus on testing that. What we do have to focus on testing is the software requirements, such as the input forms, the buttons, the tabs, and the forms. These are things you need to test to make sure your app runs, because these are the requirements that your app needs to run. So if you're going to test anything, just test all of the features that you want. And that's how you avoid making testing difficult. So how do you begin the front-end testing process? So there's only three things you need to do for each test. You need to select an element, operate, and then make an assertion. This guy over here, let's call him Bob. This is your test helper. He'll run the test for you. Bob is perfect at using the keyboard and perfect at reading code. But as you can see, he doesn't have any eyes. So he can't use the mouse to select something. He can't use the mouse to drag and drop because he can't see anything. But he is perfect at using the keyboard and perfect at reading your code. Therefore, selecting an element is done blindly, which helps with accessibility. So tests encourage accessibility using components like get by role. The get by role function will select by the name of the HTML element, and then it will look at the text of the HTML element. So here, it will select a button that says submit. This is important because a screen reader that's looking at your app will go down and say, here's a button and it says submit. Or here's a checkbox that says check me. If you know that the test is selecting using the same method as a screen reader, then you know that your code is more accessible. Get by rule should be used for most of your components that you're selecting. Get by text is for things that don't have any operations, like divs, spans, and paragraphs. You should prioritize getting by role before getting by text. And then finally, you got get by test ID. Get by test ID is best used when never. Just don't use test ID. Get by role, by text, and by test ID are ways to get from point A to point B. So imagine you're in downtown and you're trying to go around the building. Get by role is like directions. Say go left, go right, and go right again, and you're around the building. Get by test ID is like you take a hammer, you go to a building, and then you break a hole in the wall, walk through the building, and then break another hole in the wall and say you got around the building, you're at point B. Get by role is just plainly more effective. It requires less integration between your tests and your code. So after you select, you just do operation. Simplest operations are click something and type something. So you get by role of a button, and then you fire an event, click. This will click the button. Here, it's more verbose, but it will fire an event that will select the input box and then set the new text. These slashes here are a regular expression. So it's just looking for a username, an input box with username, but it could be case insensitive. This fire event is imported from React testing library to do operations. And finally, you got the assertions. You select an element, you select an element operated. Now you expect a property or an element to be in the document, have text, or be disabled, or you expect a button to be invisible. And the other operation assertions are in this link. Here's an example app to test. You got the most basic stripped down version of an app. You click it, and it starts the app. So it only has one software requirement, is that when you click it, it starts. Here's the test for it. You use a selector, do an operation, and then you make an assertion. So you select the button, click the button, and then you make an assertion based on the main content. The main content should say the word started, and this test will pass. This is the main element. So if you run this test, it'll pass. Fire events render is imported from React testing library. And the screen is the virtualized screen that a user would see. So all operations have to be done on the screen. They should be done on the screen. They could be done on the element return from render, but it's recommended to use the screen so you don't have to worry about that. You also have the description, the code, and the assertion in this test. So that's basically it. Except, bam, secret ending. Testing makes programming easy. That's what I want you to get from this. However, I was thinking of a way how to make testing more easy for advanced users. I haven't heard of anybody using this technique, so I thought I'd give a talk with it. It's about making clean tests. Now, there's no measurable benefits, but to me, it makes testing fun and easy. What is a clean test? Well, first you gotta know what clean code is. When most people say clean code, they just mean good code. And good means different things to different people, so it means nothing, objectively. What I mean by clean So I mean by clean as described by the famous book Clean Code by Bob Martin. Yes, when he's writing clean code, he has 3 priorities: readability, simplicity, and code being small. So when you're writing code, people usually have 15 lines long, and they just do operations in the function. Clean code is about separating functions that do one thing into smaller functions that each have a singular purpose. So when he says small functions, he means really small, like even 2 or 3 or 4 lines long. He also prioritizes separating what you're programming from how it's implementing. So all the implementation details go into a smaller function. And at the top of your code, you have exactly what you're trying to accomplish. That's how clean code works. This is an example of a clean test by Robert Martin. It's an excerpt from his book. It's in Java, but you don't need to understand it. You just need to know that each line, it gives a very clear and unambiguous description of what's supposed to happen, but it doesn't actually do any operations in the test. To set up a clean test, you have to import pretty DOM from the testing library /DOM and to install the just expect message. The reason you have to do this is because expect statements always have to be inside the test, because if you try and expect something outside the test, it'll just jump to the function that it ran in, and it won't point to this location. Use just expect message because you also use pretty DOM because you want to print out the state of the React application inside the expect message. So it'll only print out what's the current state of the app when the test fails. So right here, because X is 4 and X isn't 5, it'll print out, oh no. So here's the front end test again that I built for the click a button app. Compare this to the clean code, and you see every line is a description of function that he made himself. But here, I got fire event.click and screen get by role. The reason you want to use clean code is because it'll help others easily understand your code, and it'll help dumb people read your code. Who is dumb? I'm specifically talking about me at 2 a.m. If I procrastinate on an assignment on programming and I need to stay up all night, I'm not going to be operating at 100% capacity. I'm not going to be wanting to read what fire event.click does or what get by role means in my test. I just want to change one thing and then go back to sleep. So therefore, you change the test to be a clean test. This is what I think a clean test, front-end test will look like in React. Here you have the function, you start the app, and get app message. You got 2 helper functions that take the implementation details out of the test and put them into another function. I click the button, start the app, and check that the app has started. This starting the app is on its own function so that you know exactly what starting the app means. And you know exactly what reading the screen means. You know exactly what the success case looks like. And you know how to extract the success case from the screen. And when the code changes again, if somebody tells you that the app needs to do something else to start the app, or you need to get a different message, or get the app message a different way, you could change a single function, like start app, or a single function here, and you know that all the other parts of the test work. For example, if somebody changed the app requirements from clicking a button to start the app to typing out the word start, you'll be able to easily, without any thought, change exactly what the test is doing. Here, it's the same app as before, except to start the app, you have to type in the word start. And there's a input box and a label that says type here. We'll do the same thing. Go from stop to started. It's a demo for beginners, what the app does. Bam, started. How would you test that? You would just change 1 or 2 lines in the start app, and you won't have to worry about the other details of the test. So that's basically about it for this talk. So I wanted to talk more about how tests work in the real environment. So I got my terminal up here, and I got the app open that I've been copying code from. So here's the app that I just ran. Here's the app from the beginning. I mean, you got a button that says click me, and the test here. This is a basic unclean app test. Where you get by role, and then you have the content be started. Right here is the newer version, side by side. You can easily see the difference. Another reason I brought this up is because when you're really testing, here's what it'll look like when you run the test. You type in npm test, and it'll run all the tests for you. So here it'll show you exactly where the test failed and exactly where it passed. The other test passed, but this one didn't. So you just go to the app. You go to the file that failed, the example failing test. You save it, and it will automatically run the test again. So it's running again. And now all the tests should pass. So that's basically it for this talk. I'm also looking for a job in React. So either remote or in Chicago. Here's my contact info. Are there any questions? You're muted, Bill.
Awesome. Sorry about that. There's no questions in the chat. So let's just open the floor up. If anyone wants to unmute and ask a question, feel free.
Khalfani, have you been using this in your apps that you're building?
Yeah, I'll be using it everywhere because it saved me from failing.
Nice. Does it like, are you finding that it reduces your cycle time to be able to push updates like noticeably?
Yes, and it increases the confidence too, because you know that that's work.
Anything we can do to sleep better at night, you know? That was awesome. Thank you.
No problem. Also, Mitch, you have 19.5 minutes for informational interview because
Anytime. Well, I saw your message. We'll connect. Yeah, that was great.
when I timed it in practice, I thought it would be longer.
Okay, no worries. That happens. Wow, I think you answered everyone's questions in your presentation. Great job. Oh, any advice on testing backend stuff like API calls and other difficult to mock stuff from Brian?
So here's my philosophy. I think that testing actually encourages better code design. So things that are hard to test, like imperative code or effectful code, writing tests means you want to write less of that. So tests encourage functional programming, and they discourage using effects. So testing APIs, usually you just want to separate the code that you're working with and the code that actually does stuff. So separating effects from the logic, and you only want to test the logic, because testing effects means you got to set up an example, mock, and you got to set up all the other requirements. So I'd say prioritize testing the logic first.
Yeah, I would say so too. You don't want like, say if your tests are running in CI or something, for your front end, right? You don't want them actually making calls to some kind of back end. You want them to happen fast, reliable. So like, I would say you would mock those out as much as you can. Unless you're doing some kind of full integration testing, right? like using Cypress or something else, and that's a different story. But so when people say 100% test coverage, do they mean just for the essential features they decided to test in their code, or is it actually every single feature in their code? Good question.
So I was reading about Kent C. Dodds and his philosophy of don't write too many tests and mostly integration. He talks about 100% test coverage. And there's this thing called the law of diminishing returns. So the more you do something, the less benefit it has, and the harder it is to do something. So when they say 100% test coverage, they actually mean test everything. But in front-end development, according to Kent C. Dodds, you shouldn't be trying to test everything because there's a diminishing effect. So I say when you're learning, prioritize the important stuff, because testing is fun and it makes programming easy. Once you learn how to test the easy stuff, then you can decide whether you want the extra effort to test everything. And tests can sometimes make it harder to change stuff if you're testing all the details. Because if you have too many tests, then you're stuck in that position.
Yeah, and then there's the whole testing pyramid, right? So like the bottom third is like the unit test. In the middle, it's like your integration test, right?
Yeah.
And your little top part is like your end-to-end test. Yeah, I mean, I've never really subscribed to the thought of 100% test coverage. I mean, I feel like anything above 80, 85% is pretty good. So otherwise,
well, here's my question is, if you're sitting there saying that there is some percentage of testing coverage, etc., that beyond that is diminishing returns, then is there a flip side where you're saying that there's an acceptable level or number of bugs in your code that is acceptable?
I don't know. Are you saying that if you have 100% test coverage, you're gonna not have any bugs?
No, but I'm saying that the lower percentage of coverage you have increases the likelihood of having a bug. And therefore, at some point, you're setting an arbitrary number of acceptable bugs for your software.
Yeah. It also depends how good these tests are written to begin with, right? Because it's easy to just write a test that covers all the different paths of all the different paths, right? Of like, say, a function or a module, but not to really test it at the same time, right? So it would register as 100% test coverage, even though maybe your test wasn't even that great, right? I think it's complicated, right? It's a little more, kind of more of a gut feeling on how your test suite is, how good it is, and what it actually tests. I mean, you definitely want to get the meat and bone of, like, of the logic of what you're testing. If there's some other conditional logic that's like more as like, I don't know, just more as like not that critical, I don't know what's the use of having a test case for it. Thus the whole 85-90% test coverage. Khalfani, what do you think about that?
I think, sure, if you have more tests, you have less bugs. What I think is, people can write good code and good front-end applications without any tests at all and just manually test it. We're not trying to write NASA applications that guide spaceships. So we wouldn't be writing thousands of tests for thousands of possible states that a program could be in. So there's an acceptable level of things that we're just not going to account for. So everything that we decide on is basically arbitrary because we don't have any actual metrics. So if you could sleep at night knowing that you're going to have to probably manually test something versus spending a couple extra hours trying to test everything, then that's just a trade-off you can decide on your own individually.
Okay, I'm going to tell you a true story from my programming past. And the situation was, I was working on a product called Office Vision, which was ultimately replaced by Microsoft Notes, etc., or the Office system. But it was mail and a text editor and print. And it was a mainframe application. And some bright programmers over in Germany wrote this add-on to it that would allow you to fax a created document, a document that was created in this application. And in their testing, there was a parameter that if it was set to true, their application failed. So they changed their documentation to say, when you're installing our fax add-on, you have to set this parameter to false. Well, the trouble is that parameter that you were setting to false was telling our application that there was a printer application attached. And so basically they were disabling printing of any document from our Office app. So in a way that is a testing, it's a failure of testing, and it's a failure of the interface. And they had actually spent a couple $1 million developing the application, and it was ultimately just trashed because it would not function the way they developed it to work with the rest of the application without breaking it.
So it failed because of a single Boolean value?
No, it was what that Boolean value represented. What actually was going on way beyond the scenes was that Boolean value was saying, okay, the print ability is there, which then created a whole series of memory allocations and other interfaces underneath in the code. And now what was happening was their fax software was overwriting and competing with the print drivers.
Nice.
And creating very unpredictable results.
So they really could have used some version of native testing library? They really could have used something like that back in the day, huh?
Yeah, it was more, of understanding what their tests were telling them and understanding all the, some of the other permutations of the software that they were attaching to.
So I think that's definitely an unfortunate case, and more thorough testing would have caught that because it's really at the interface layer. But that seems kind of like a one-off thing. I'm sure this sort of thing happens all the time, but I don't think it's as easy to say we need 100% test coverage or we don't. The world's just a lot of gray,
Yeah, I'm saying that too, but I'm saying and I don't know what the answer is, but there's got to be some level of testing to provide a fairly reasonable level of certainty that the software is going to work the way it was designed.
I have a hard time like codifying that because I think it depends on the context and like what works for your team and the error budgets that you've created for yourself, you know?
I agree to you to some extent, but I also want to go forward a little bit further and say it also involves the impact that potential errors in that section can cause. And, you know, if it's a trivial error of a wrong color showing up, you know, on a screen, I'm not going to be so worried about it. But if it's a medical application and it's slipping decimals and giving somebody 100 times the dosage of a drug that's going to kill somebody, I'm going to want a little bit more robust testing.
We're totally on the same page. I think it's all about that context.
Yeah.
Yeah.
Yeah, like a lot of different answers. It depends, right? There's like so many different variables and different contexts and all that stuff. So yeah. Hey, it's not bad to have, you know, a good percentage automated tests, but I always like to have a human element in it too, and have a manual, QA team.
Mm-hmm.
That's what I had at Yum, right? Even though when I was at Yum, I was being guided towards more of having QEs instead of QA, right? So more of automation engineers. That's good in one respect, but yeah, I just love that human element too, to be able to test things on intuition and stuff like that. So I think it's good to have all the different combinations to have a really good product. Anyways, I don't think we got any other questions. So floor is open. If anyone wants to chat anymore, or if everyone's done for the day. Thanks for everyone coming out. Thanks for Khalfani for volunteering to give a talk. He's in St. Louis right now, and I know he's been coming to the last couple different virtual React meetups here, and it's just great. It's just a great initiative that he's shown to be able to get up and give a talk. His first talk, I believe. Is that right, Khalfani? Your first talk?
Yeah.
Oh, that's awesome. Congrats.
Yeah, awesome. Congrats.
Thanks.
And hopefully, getting that up on the React YouTube channel, we'll get you some publicity there, and you get all the offers pouring in here. It's a good job market to be in right now. So if anyone's hiring, please give a shout out to Khalfani. Otherwise, that's it. If everyone's done.